Now let's discuss about the normal distribution, right? So normal distribution is basically a simple, thing if you understand the basics of data distribution, probability distribution. But if you are not really comfortable with it, you might find it daunting if you try to get real understanding of it. But luckily, most of the questions that you get don't really need you to know a lot. But it's good if you are somehow linked to statistics, or maybe artificial intelligence, machine learning, or anything you're looking at. It's a good thing to know, obviously. So let's talk about normal distribution. So fundamentally, right, the normal distribution is one of the types of data distribution that are assumed when we formulate some concepts. There are other like binomial distribution, right, Poisson distribution, etc., in the statistics, but there are certain rules based on which you will use normal distribution. So generally the distributions are used for this. I have a sample. I cannot measure the population. So let's say I am trying to find out the height, the distribution of heights, like how the behavior is in a country like India. Finding for the population of 130 crores or 1.3 billion is a big task, right? You can't get the heights of each and every one and then sort of plot how it looks like, right? How people are with respect to the heights. So what we do is, rather to make it a good estimator, we pick a sample. There are multiple sampling methods, we don't get into that, but let's say I pick a sample of 1000 people, right? I pick some 1000 people in the country. I measure their heights and I plot the distribution based on certain conditions, right? I understand, or maybe I assume that it follows a normal distribution. Then I can say that whatever the behavior I see for the 1000 people, the distribution I see, that is what the entire country would also show. That's a bigger assumption that I am assuming. Right, so that's the whole idea of normal distribution. You have central limit theorem, when would you do assume and all those stuff. I don't want to get into that. Just that normal distribution is simply for us to understand is this data distribution, right? Let's say I have distribution of some scores or heights or anything of some people, and then I'm plotting that. So generally the plotting would go like this. These are the measurements. Let's height like 130 centimeters, 140 centimeters, etc. Or sometimes you put a range as well, 120 to 130, 130 to 140, 140 to 150. And then how many people are there, the frequency graph is what you'll draw. But what you do is, pick the heights and then, you join them and sort of get a curve. That's what the normal curve would look like. So let's just get into a simple thing that you need to understand. The first and foremost case is that in the question you would read this word called a data is following normal distribution, right? Normally distributed or something like that. Then only use this. You won't use this concept everywhere. That's a good part in the exam, that they would give you a hint like it is following a normal distribution. Generally we call them bell curves. It look like this. That's why we call it a bell curve. There's skewed to right, left, all of this is also not required. Leave that part. So this part, this x-axis is the measurements that we were talking about. Right, let's say I have 400 people and I've measured the heights. So the things that would be given are, that something that you need to know is this, okay? Mean of the data, right? I have 400 people. I would be like, person 1 is 120 centimeters. Person 2 is 140 centimeters. Let's say something like this, right? So I have 400 people heights I've recorded. So I can show this data visually like this. It follows a particular distribution. So how do I construct it? As I said, it would be done like, like 120. I know 5 people are a range of 120 to 130. There are 5 people in the data. 130 to 140, there are 6 people, something like this. I join the peak points, I get a curve, and that's what this is. So let's not get into that. It's not required how you construct it. So what you need to understand is this, that I need to know mean, and then I also need to know the standard deviation of the given data. Right? Mean generally is put in a mu and this is put a sigma. So, right, otherwise what other way we write? So that's how you construct this curve also. I mean, to just interpret rather than construction, that's a wrong way, but interpret it. So the peak you see is basically the mean value. As I said, this is the measurements, right? This would have heights. On the x-axis I should have heights because this is heights. Then I split this mean plus standard deviation. Then this will be mean plus 2 times the standard deviation. Right? Similarly, here I have mean minus standard deviation, and this will be mean minus 2 times the standard deviation. So the way should be mu plus sigma, mu plus 2 sigma, mu minus sigma, mu minus 2 sigma. This is how you would call this. So what happens is this, okay? I can split the data into groups like this. I know that out of the whole data I have, 34% of people would be between this mu and mu plus sigma. 14% will be between mu plus sigma and mu plus 2 sigma, and 2% will be here. Similarly, 34% here, 14% here, and 2% in the remaining part. How do I know these percentages? These are empirical, okay? It's like through some consistent data research, what the results are for the population, they have derived this. So you don't have to understand how they got this, but you have to remember these numbers. First and foremost, what is this peak? Is the mean. Also understand this is the median and this is the mode as well. If you get a normal distribution curve and ask, okay, what is the mean of this data is, let's assume, okay, I'm measuring 400 people height and I give you the mean is 160 centimeters. Right, the average height or the mean height of the data is 160. What is the median height? 160. What is the mode height? 160. Right, this is what happens in a normal bell curve. So there are bell curves which are skewed, like normal distribution which are skewed to right and left. Here it's a different story, but here it is the same, right? A bell curve which is symmetrical, which is what the questions are asked in the exam. You don't have to go beyond it. So we'll stick to this. So it's a symmetric one because, as I said, you see this. What is 34 plus 14? 48 plus 2 is 50. Everything to the right is 50%. Everything to the left automatically 34 plus 14 plus 2 is 50%. The whole sum is 100%, right? That means this 100% of people that I have, the data sample I have, or whatever the data I have, I am splitting them into this. So I'll give you an example with some numbers to make it a bit clear. So let's take the same example, right? The mean came 160, standard deviation came to be 10. What does this mean? 160 centimeters, this is 160 plus 10 is 170, this is 160 plus 20 is 180, 160 minus 10 is 150, 160 minus 20 is 140. So what am I saying? How many people are taller than 160 centimeters? That is to the right is 34 plus 14 plus 2 is 50%, right? So I know that 50% of people are taller than, in this sample I have taken, this is the distribution for this. I know that 50% of them are taller than 160 centimeters. How many people are taller than 170? That is to the right of this point, right? 170 is this, everything to the right is more than 170. So I know 14 plus 2 is 16% is taller than 170. If I ask you how many people are shorter than 150, 150 shorter than this is to the left, less than 150 is 140, 147, all of those things, right? 14 plus 12. So 16% of them are shorter than 150 centimeters. If I ask you how many people are between 150 to 170, right, their heights are between 150 to 170, that is talking about this and this zone, which is 34 plus 34 is 68%, right? So 68% of 400, so I can find out the number of people who are between that. That's how the questions are framed, okay? Type 1, they give you these two, they ask you how many people are between a particular value, right? I can as well say that 174 centimeters is let's say 85 percentile or 90 percentile, let's put it 90 percentile, right? How many people are between 174 and 170? I know that this is 14 plus 2 16, right? That means this is automatically 84 percentile. There are 16 people to the right, the other 84 will be to the left, so 84 percentile. The 90 percentile is 174. So how many people are between 170 to 174? Between 84 and 90 is 6%. That's how you do. This is the next level complication that you could see, right? Otherwise, simple figures is what you need to use. Other type you might also get is this, where I don't give you these things, okay? I give you one of these two, I might not give you other, and then I'll give you the percentiles which you can use to find out this. That's something that could be also asked. So let's see some problems, you'll get an understanding of that. So a simple example is this, that income of 8,000 families of town X are normal distributed. This is the clue. Then and only then you would use the normal distribution curve. Otherwise you would not. They gave standard deviation, they gave mean. I know mean. I know the standard deviation. So first and foremost, when I know it, what would I do is I would draw the x-axis. This is 60,000. Mu plus sigma, that is 65,000. Mu plus 2 sigma is 60 plus 2 into 5 is 70. 55,000, and this is 50,000. This is the first step you need to do. When I know mean and this, that's what I do. Then what will I do? I'll draw a bell curve. Something like this. And I know this are the zones. 34%, 34%, 14, 2, 34, sorry, 14, and this is also 2%. That's how the split is 2, 14, 34, 34, 14, 2. Find the number of families which earn more than 65,000. How many families earn more than 65,000? That is to the right? So this is just the 14 plus 2. 16% of 8,000 families is what I see in the town X. So that is the answer for the first question. How many families earn more than 65? 16% of 8. So that will be, right, 120, right, 1280. 1280 is the number of families. This is the easiest one I'm talking. The slightly complicated is this, where I would say family A earns 52,000, that is somewhere here, 52,000, and the percentile is given to be 10 percentile. Find the number of families that earn between 52 and 65. So 52,000 is earned by, that is 10 percentile. What about 65,000? What is this percentile? 34 plus 34 plus 14 plus 2, right? Percentile is to the left. How many are less than that? 34 plus 68 plus 4 is 72 and 2 74, right? So I know this is 74 percentile. So how many families earn between this? 74 minus 10 is 64%. So 64% of 8,000 families earn between this value, right? That's what you have to do. Like how we did in box plots, all you need to understand is the percentiles for these values. Okay, mu is 50 percentile, mu plus sigma is 74 percentile, this is 98 percentile, this is 16 percentile, and this is 2 percentile, right? These are the standard numbers also somewhere.